Something is wrong, and the strange part is that it may not be hidden anymore. It may be happening in plain sight, everywhere at once, so quietly that you only notice it when you step back and realize the whole structure is slightly off, like a house that still stands but no longer feels level beneath your feet. For a long time you were told the universe is governed by laws as steady as bedrock, rules that do not bend, do not hesitate, do not improvise. Gravity pulls the same way today as it did yesterday. Light travels with the same stubborn obedience. Atoms, fields, time, space, all of it fits together with the cold elegance of a machine that does not need to be reminded how to work. And yet the deeper you look, the more the machine seems to be stuttering. Not once, not in one place, repeatedly, across scales, across disciplines, across the very frameworks that were supposed to explain everything else. If you have felt at times that reality is behaving as though it is forgetting its own instructions, that is not just poetic discomfort. That feeling sits at the edge of a scientific unease that is becoming harder to dismiss. The universe was supposed to be the great example of consistency. You were supposed to trust that if you understood the rules, you could understand the outcome. Drop an object, and it falls. Heat a gas, and it expands. Observe a distant star long enough and its light tells a story. The laws of physics were presented almost like a sacred grammar for reality, a hidden sentence structure beneath all the noise. Even when things looked chaotic, the laws themselves were meant to remain calm. The weather may be messy, but fluid dynamics still holds. Matter may clump, collide, and explode, but chemistry still works. Galaxies may spin into glittering spirals and black holes may swallow light, but underneath that drama, there is supposed to be a stable mathematical backbone holding everything in place. That idea has been one of the most reassuring achievements of human thought. The universe is not random, it is not improvising, it follows rules. And because it follows rules, it can be known. That is the promise at the center of science. Not certainty about every detail, but confidence that the rules themselves will not secretly change while you are looking away. But the first cracks do not begin with catastrophe. They begin with small impossibilities, the kind that look harmless until you realize they should not exist at all. A measurement that refuses to match the prediction, a value that drifts where it should remain fixed, a cosmic observation that arrives like a whisper in a room where everyone thought the door was closed. There is a particular kind of scientific dread in hearing the phrase, "This should not happen," because it means the universe has done something more unsettling than break a rule. It has behaved as though the rule was never there. You can almost forgive a single anomaly. Nature is complicated, instruments fail, interpretations differ. But when the anomaly repeats, when it reappears in different guises, different regions, different epochs, it stops looking like error and starts looking like resistance. Something is pushing back against the picture you thought was complete. Something is revealing a seam. One of the strangest places this seam appears is in the sky itself. Astronomers build their understanding of the cosmos on the behavior of light, and light is supposed to be one of the most disciplined things in the universe. It travels, it redshifts, it obeys the geometry of space-time. It tells you how fast galaxies are moving, how far away they are, what they are made of, how the universe has expanded over time. But then the numbers begin to misbehave. The rate of cosmic expansion, for example, does not seem to agree with itself depending on how you measure it. Different methods, both respected, both careful, both grounded in evidence, keep producing results that refuse to line up neatly. The universe appears to be expanding in a way that is either inconsistent, misunderstood, or actively hiding something. This is the kind of problem that sounds technical until you understand the emotional force behind it. It means the cosmos is giving different answers to the same question. If that were the only issue, you might still try to keep your footing. Maybe the measurements need refinement. Maybe the models need adjustment. But that is not the only crack. Another one opens in the realm of the very small, where the behavior of matter becomes stranger than intuition can comfortably hold. Quantum mechanics, for all its success, describes a world that does not sit still long enough to feel secure. Particles seem to exist in states that only become definite when observed. Events do not always look like events until they are measured, and even then the outcome appears to be drawn from a set of possibilities rather than dictated by a single visible cause. You can build exquisitely accurate theories around this behavior, yes, but you never quite shake the sensation that the underlying reality is not just obscure, but unstable in a way classical physics never prepared you for. The small world does not merely surprise you, it erodes your trust in the idea that what is happening is always a settled question. That would already be enough to unsettle a person if it stayed neatly compartmentalized. The large world is one thing, the small world another. But the trouble is that the anomalies do not remain in their lanes. They begin to echo. You see tension in astrophysics, and then in particle physics, and then in precision tests of constants that were supposed to stay constant. You see disagreement over the age and rate of the universe, and then over the behavior of matter under extreme conditions, and then over whether the same physical laws that work so beautifully here can be trusted everywhere else. The pattern is not that everything fails at once. It is that everything remains mostly functional just long enough for the failures to look accidental, and yet those failures keep accumulating in places that should not be talking to each other. It begins to feel less like isolated malfunction and more like a system under strain. There is a reason this is so disturbing. Humans can tolerate mystery. What we struggle to tolerate is inconsistency. A mystery implies there is an answer somewhere, even if it is hidden. Inconsistency suggests the answer may depend on where you stand, how you look, or whether the universe feels like cooperating at all. So when one part of physics says one thing and another part says something that cannot peacefully coexist with it, you are no longer looking at a simple missing piece. You are looking at a contradiction embedded in the foundation. General relativity describes gravity as the curvature of space-time, smooth and continuous, a cosmic architecture where mass tells space how to bend and space tells mass how to move. Quantum mechanics, by contrast, describes reality in discrete probabilities, flickering uncertainties, and interactions that are not so much smooth as jagged with possibility. Both frameworks work astonishingly well in their own domains. Both are indispensable, and both cannot be fully right in the same way at the same time. The universe, apparently, is committed to being legible in two languages that do not fully translate. That incompatibility would be an intellectual problem if it stayed on the blackboard. Instead, it becomes a physical problem when you ask what happens in places where both rules should matter at once. Inside black holes, at the beginning of the universe, in conditions so extreme that space-time itself should tremble under the weight of what is happening inside it. There, the elegant continuity of relativity and the granular probability of quantum theory slam into each other like two maps drawn at different scales over the same territory. One says space and time can be smooth enough to model. The other says the world is restless down to its roots. When you try to merge them, the equations begin to protest, not with a clean answer, but with infinities, contradictions, and stubborn gaps. It is as if reality allows you to see two different operating systems but refuses to let you access the source code. And still, the anomalies do not stop at theory. They begin to seep into observation like water finding cracks in concrete. Astronomers notice discrepancies in the behavior of galaxies that do not fit the expected distribution of matter. Particle physicists encounter results that deviate from predictions by just enough to matter, but not enough to settle the issue. Precision experiments become more precise and yet somehow make the picture less certain. The more carefully you look, the more the numbers seem to lean away from the model. That is a particularly unnerving form of failure, because it suggests the issue is not ignorance in the usual sense. It suggests that improved clarity does not always lead to harmony. Sometimes clarity makes the dissonance louder. You might expect at this point a singular breakthrough, some elegant correction that patches the divide and restores confidence. That is the usual story of science, after all. A model fails, a better model appears, the world becomes a little less mysterious. But this time the pattern behaves differently. The contradictions do not collapse into one simple explanation. They multiply. Different areas of physics offer different hints, none of them fully convincing, all of them desperate in their own way to preserve the idea that the universe is still fundamentally coherent. Dark matter is proposed, then questioned. Dark energy is introduced, then treated as a placeholder for ignorance. Inflation, extra dimensions, modified gravity, exotic fields, hidden symmetries, untested parameters, each one an attempt to keep the structure intact while acknowledging that the structure is not behaving as expected. It is not that scientists are confused in a casual sense. It is that the universe keeps producing the sort of confusion that is intelligent enough to resist being boxed in. At first, the failures seem localized, but then you notice a more unsettling quality to them. They are progressive, not in the sense that every new result is more dramatic than the last, but in the sense that the domain of certainty is shrinking. Where once the equations felt like a map of reality, now they feel like a set of approximations with increasingly visible edges. The old confidence that physics can be divided neatly into solved and unsolved problems begins to erode. Some of the most cherished constants in science are tested for drift and rechecked for stability, because even the possibility of change in those constants would imply that the universe is not merely operating under laws, but perhaps under conditions. That would mean the rules are not as eternal as they look. They may depend on something deeper, older, or stranger than the laws themselves. And if the laws can depend on something else, then the laws are not the final story. They are only the visible layer. The disturbing thing about a visible layer is that once you suspect it is a layer, you cannot stop asking what lies beneath it. This is where the psychological shift begins. You stop seeing physics as a completed picture and start seeing it as a fragile interface. You stop imagining laws as commandments written into the fabric of existence and start wondering whether they are more like habits of the universe, patterns it has learned to repeat. That possibility should not feel threatening, but it does, because habits can change, habits can drift, habits can break under stress, and if the deepest regularities of reality are not truly fixed, then the universe is not a machine in the old sense. It is something more contingent, more adaptive, more vulnerable to unknown influences. You begin to feel the ground beneath scientific language thinning into ice. This unease sharpens when you consider how many of the universe's supposed certainties are really just large-scale averages of smaller uncertainties. Time feels continuous because it does not usually interrupt you. Space feels stable because at human scale, it is. Causality feels sacred because causes usually precede effects, and the world would become emotionally uninhabitable if it did not. But the deeper you descend, the more those assurances lose their clean edges. Quantum events do not always behave like miniature clockwork. Near black holes, time stretches into something almost unrecognizable. At cosmic scales, the expansion of space seems to accelerate under a pressure no one fully sees. In every direction, stability appears less like a fundamental property and more like a temporary agreement between layers of reality that are not always aligned. You start to suspect that what you call order is just the part of the universe that has not yet revealed its disagreement with itself. There is another reason the current situation feels worse than a normal scientific puzzle. Normally, when a theory fails, the failure has a shape. It is confined. It points somewhere. But here the failures spread across the map in a way that makes the map itself suspicious. If general relativity breaks down in extreme gravity, perhaps quantum mechanics will rescue it. If quantum theory becomes ambiguous at the largest scales, perhaps a deeper theory will unify them. But what if the issue is not simply that two theories are incomplete? What if the universe is not a single uniform system at all? What if the laws we trust are only local descriptions, rules that hold because we are positioned inside a particular region of reality where those rules happen to apply? That would mean physics is not the language of everything. It is the language of here. Once that idea enters your mind, every new anomaly feels heavier. A discrepancy in the cosmic microwave background is no longer just data. It is a reminder that the early universe may not have been as cleanly described as you hoped. A surprise in the behavior of elementary particles is no longer merely a curiosity. It becomes another sign that the most basic ingredients of matter may be showing pressure from underneath. A mismatch in expansion rates becomes more than a cosmological inconvenience. It becomes evidence that the universe may be telling different stories depending on which relic or method you ask. And the most unnerving part is that these stories are not obviously false. They are all plausible enough to keep the argument alive, which means the universe is not handing you a simple fracture. It is handing you ambiguity that survives scrutiny. Scientific culture responds to this kind of ambiguity with admirable discipline and a kind of restrained panic. Researchers test again. They tighten error bars. They compare methods. They design better instruments, larger surveys, more sensitive detectors, more carefully isolated experiments. They propose new frameworks, then try to break them with data. They argue, revise, retract, refine. This is how science is supposed to work, and it is one of the reasons science is so powerful. But from the outside, watching this process in a moment of genuine instability, you can feel the tension in it. Every explanation sounds provisional. Every model arrives with hidden disclaimers. Every confident statement is followed by some version of, if this holds, unless this changes, assuming this scale, provided the system is isolated. The language of certainty becomes increasingly conditional, and the conditions begin to multiply until certainty itself feels like a luxury of simpler times. Meanwhile, the universe keeps producing evidence that our confidence may be too neatly packaged. Consider how often physics depends on the assumption that the same rules apply everywhere. The farther you look, the more pressure that assumption receives. The early universe may have been governed by conditions unlike anything accessible today. Extreme gravitational environments distort familiar behavior. Quantum phenomena seem to defy intuitive continuity. Even the vacuum, that supposed emptiness beneath everything, is not empty in the way common sense imagines. It seethes with fluctuations, virtual activity, and fields that refuse to stay still. So what looked like solid foundation starts resembling a negotiated truce among unstable processes. Perhaps there never was a perfectly static bedrock. Perhaps the bedrock was always moving, just too slowly for human perception to detect. And if that is true, then the phrase laws of physics begins to sound less like a decree and more like a description of recurring behavior. That distinction matters. A law in the human imagination is absolute. It governs, it commands, but a description only holds while the pattern holds. If the pattern changes, the description ages. If the conditions shift, the law may appear to fail without ever having been universal in the first place. You can already feel how unsettling that possibility is. It implies that what we have called the laws of nature may be more like local customs in a much larger reality. Customs that could vary, evolve, or even fade. That would not just alter science, it would alter the meaning of certainty itself. You are no longer dealing with an eternal script. You are dealing with a living system whose rules may be more fragile than its behavior suggests. The conflict between relativity and quantum mechanics is where this fragility becomes hardest to ignore, because the two theories are not small supplements to science. They are pillars. One governs the immense, one governs the minute. Together they explain nearly everything we have been able to test, and yet together they fail to fully describe the situations where reality seems most extreme and most revealing. That failure matters because black holes in the beginning of the cosmos are not edge cases in a trivial sense. They are where the universe writes in the boldest possible lettering. If the laws cannot agree there, then the most revealing moments in reality are also the moments where reality seems least willing to explain itself. It is like finding that the alphabet breaks apart precisely when you try to read the first sentence of the book. You may notice now that the unease is no longer just about science. It is about trust. Not trust in researchers, who are doing what they can with extraordinary care, but trust in the assumption that reality is coherent enough to be understood by beings like you. Human beings evolved for practical survival, not for a faithful intuition of space-time or quantum fields. You navigate the world through rough approximations, pattern recognition, and a sense that most things remain themselves when you are not looking directly at them. Science extends that intuition far beyond its original range, and usually it works. But every anomaly reminds you that your mind is not a sovereign interpreter of reality. It is a negotiator with it, and sometimes the negotiation fails. That failure has psychological weight because it threatens one of your deepest comforts, the belief that the universe is dependable, even when it is mysterious. A dependable mystery is tolerable, an unreliable reality is not. So when you begin to see data that suggests the cosmic expansion rate might not fit neatly into a single story, or particle results that sit awkwardly outside expected ranges, or astrophysical structures behaving in ways that strain current models, the discomfort is not merely intellectual, it is existential in miniature. If the universe can misbehave in measurable ways, if the framework can produce tensions that do not fade with better instruments, then you are forced to wonder whether the stability you feel in ordinary life is merely a local illusion. The floor might only seem solid because the cracks are too vast to see from here. There are moments in science when uncertainty is productive, when it opens a path, and then there are moments when uncertainty starts to resemble a surrounding atmosphere, something you breathe rather than solve. This feels more like the second kind. Not because the answers are impossible in principle, but because every answer seems to reveal a wider question behind it. If dark matter exists, what is it interacting with and why in such a strangely invisible way? If dark energy drives expansion, why does it have the value it has? If space-time is curved, what happens to curvature at the smallest scales? If quantum probabilities are fundamental, why does the macroscopic world remain so stubbornly consistent most of the time? Each explanation is like opening a door to a hallway that does not end where it should. The building keeps extending. And now, perhaps most unsettling of all, some physicists begin to wonder whether the laws themselves may be emergent rather than fundamental. That is a very polite way of saying the rules you trust might be an outcome of something deeper, not the bedrock, but the decoration painted onto it by a hidden process. Thermodynamics already taught you that large-scale order can emerge from microscopic chaos. Maybe space-time, maybe gravity, maybe even some aspects of quantum behavior are not the deepest level of reality, but the visible surface of a more primitive substrate. If that is so, then the universe may not be following laws so much as generating them. And if laws can be generated, they can potentially vary, evolve, or fail under conditions you do not yet understand. This is the point where the phrase "laws of nature" begins to sound almost sentimental. The intuition that reality may be layered is not new, but it becomes more haunting when current anomalies seem to point in that direction simultaneously. You start to imagine hidden frameworks beneath the ones you know, not in a mystical sense, but in the sense that every reliable description may rest on a deeper mechanism. Maybe space-time is a kind of projection. Maybe quantum behavior emerges from information we cannot yet access. Maybe the vacuum is not the bottom, only a threshold. These are not fantasies pulled from nowhere. They are attempts to make sense of genuine tensions, but each attempt also brings you closer to a difficult possibility, that your view of the universe is not merely incomplete, but structurally limited. You may not be missing one final equation. You may be missing the entire class of thing that would make the equation possible. That is where the simulation hypothesis begins to hover at the edge of the conversation, not as an answer, but as a symptom of how strange the questions have become. If reality is computational, if physical laws are outputs of a deeper information process, then anomalies might not indicate failure of nature but limitations of the underlying rendering. Yet even that idea, provocative as it is, does not solve the unease. It only relocates it. If the universe is computed, then why are the computations inconsistent? If there is an underlying system, why does it appear to hesitate or drift? If there is a deeper layer, why does it sometimes leak into ours as contradiction? The problem remains, only now it feels taller, with more floors and fewer rails. And if none of this is a simulation, if reality is simply reality, then the implications are arguably even more unsettling. Because then the laws are not enforced by anything outside the universe. They are either intrinsic or they are not. If they are intrinsic and still appear to bend, then the bending is part of reality's own nature. If they are not intrinsic, then the universe is governed by something contingent, something conditioned, something that can in principle change. Either way, the dream of absolute permanence weakens. You are left with a cosmos that looks less like a sealed machine and more like an ongoing process. A process that may have begun, may be changing, and may not care whether human beings are comfortable with the pace of its transformation. It is easy to miss how deeply this affects your sense of time. You usually imagine time as a clean arrow, a one-way path along which events unfold. But if the stability of physical law is not guaranteed, then time itself becomes harder to trust. Not because you will suddenly see clocks running backward, but because the meaning of sequence, persistence, and cause begins to feel less absolute. Relativity already showed that time is not the universal metronome common sense hoped for. Quantum theory already hinted that the future may not be as rigidly determined as you once believed. Put those together and you get a universe where time is not a river, but a negotiated effect, something that may emerge from deeper relations rather than define them. The thought is subtle, but it lands like cold water. If time is less fundamental than it seems, then even the idea of a stable universe may be built on a more fragile foundation than anyone wanted to admit. Space, too, starts to look less like a stage and more like a participant. For centuries, it was natural to think of space as empty room, the silent container in which things happen. But modern physics transformed that empty room into a dynamic field. Space can stretch, warp, ripple, and perhaps even quantize in ways invisible to the eye. If space itself is not immutable, then the location of events is not as simple as it sounds. Reality becomes a kind of negotiated topology, shaped by matter, energy, and perhaps deeper processes we cannot yet isolate. This matters because once space is dynamic, the idea of stable distance, stable separation, stable position begins to lose some of its certainty. You are no longer standing in a fixed arena. You are standing in something more like a living membrane, one whose geometry may not be as settled as it seems. Causality is the final comfort, and perhaps the most vulnerable one. The belief that cause comes before effect is the scaffolding of everyday reasoning. It lets you plan, predict, and narrate your own life. Yet at the edges of physics, causality is not always as simple as the story you tell yourself. Entanglement, delay, horizon effects, exotic space-time geometries, all of these raise questions about how events relate to one another at a fundamental level. No one is claiming that causes and effects are meaningless, but the deeper you go, the less obvious it becomes that causality is a universal law rather than a macroscopic pattern that mostly works because you live in the right regime. If that pattern ever weakens, even locally, then reality is not merely strange. It becomes narratively unreliable. Once the universe is no longer narratively reliable, every contradiction becomes more than a technical mismatch. It becomes a warning that the story you thought you were inside may be incomplete at the level of structure. Scientists do not like to speak this way because the language sounds too dramatic for careful work. But careful work is exactly what has produced the tension. That tension forces careful language to carry emotional weight it was never designed to bear. You hear phrases like tension in the standard model, discrepancy in the constant, unexpected deviation, statistical significance pending confirmation, and beneath that professional restraint you can feel the strain of a civilization trying to keep its composure while the wall behind the wallpaper begins to bulge. The scientific response is not denial. It is discipline. It is the relentless refusal to overstate, even when the evidence is unsettling. That discipline matters because it protects inquiry from superstition. But discipline does not erase the feeling that something foundational is being tested by events no one fully expected. Competing theories emerge not because scientists are careless, but because reality has become difficult enough to demand multiple possibilities. Maybe gravity must be modified. Maybe hidden particles are at work. Maybe our understanding of cosmic history is incomplete. Maybe the vacuum energy problem points to a missing principle. Maybe the universe is telling us that our current language is too blunt for the fine structure beneath it. The burden of explanation grows heavier, and the explanations themselves begin to feel like scaffolding around a building that has not yet revealed its true shape. The deeper problem is that every scientific answer is provisional, but some provisional answers become the only thing holding back a larger uncertainty. You see this in cosmology, where the story of cosmic inflation, dark matter, and dark energy has become a strange architecture of placeholders and inferred entities. You see it in particle physics, where the elegance of established models coexists with hints that something is missing, something perhaps more fundamental than the current framework can show. You see it in the measurement of time, in the behavior of black holes, in the strange silence between theory and observation. The universe is not shouting its secret, it is leaking it through cracks, and the cracks are multiplying. At some point, the question stops being, which theory is wrong, and becomes, what if wrongness is the wrong category? What if the universe is not violating laws because it is broken, but because the laws were never meant to be permanent in the first place? That idea should offer comfort, because it would turn chaos into evolution. But it does not comfort you, because evolution still implies change, and change at the level of law is far more disturbing than change at the level of detail. A law-changing universe is a universe in motion deeper than matter, deeper than energy, deeper than the equations you use to describe them. It means the rules are not the ceiling, they are part of the weather, and weather can shift. If you sit with that thought long enough, you begin to feel the room around you differently. Not physically, not in any dramatic supernatural sense, but psychologically, as though the atmosphere itself has become more alert. You become aware of how much of life depends on continuity. The table remains a table, the floor remains the floor. Your memory remains connected to your present. The stars continue to burn in patterns that let you infer history. Reality is usually generous in the consistency department. That generosity is what makes existence livable. The possibility that it may not be guaranteed feels like a quiet pressure at the base of thought. You do not need a dramatic rupture to feel it. You only need the accumulation of small, unresolved tensions. Eventually, tension becomes texture, and texture is how instability often presents itself before collapse. Not a dramatic break, but a roughness, a slight resistance where smoothness was expected. That is what makes the current scientific moment feel so charged. Not because the universe has visibly fallen apart, but because it keeps showing you that the assumption of smoothness may have been naive. Cosmic expansion is not behaving as simply as expected. Fundamental theories are not cooperating as hoped. Constants are being watched for drift. Quantum behavior remains deeply strange. Gravity and space-time refuse to merge cleanly with the microscopic rules. You can continue to call this a set of open problems, and that would be technically correct, but emotionally, it feels more like a universe that is no longer content to remain neatly summarized. There is a subtle horror in the possibility that human beings are only now becoming aware of the limits of their cosmic access. For most of history, ignorance looked like darkness. Then science turned some of that darkness into measured distance, named particles, mapped forces, and predicted events. It was tempting to believe the glow would keep spreading until no mystery remained except the ordinary complexity of detail. But what if there is a horizon built into perception itself? What if the universe is not fully available to minds that evolved for survival instead of comprehension? In that case, the laws you have discovered may be less like the universe's final architecture and more like the border of a language your species can speak. The rest exists, but not in your grammar. That possibility opens the door to a much larger unease, because it suggests that reality may be consistent in a way that is simply inaccessible to you, or inconsistent in a way that you cannot yet measure cleanly enough to name. Both options are unsettling. One tells you that truth exists beyond your reach. The other tells you that truth itself may be uneven at scales too deep for current tools. Either way, the comforting notion that science is steadily approaching a final picture begins to fade, not because science is failing, but because the target may be more complicated than a final picture can hold. You may not be approaching a picture at all. You may be approaching a threshold, and thresholds are dangerous because they are where categories become unstable. A threshold is where one thing becomes another, where the familiar no longer fully applies. Physics has been discovering more thresholds than it knows what to do with. Between classical and quantum behavior, between gravitational regimes, between energy scales, between cosmic eras, between theoretical elegance and observational surprise. Each threshold is a reminder that reality does not always transition politely. Sometimes it changes phase. Sometimes the rules are rewritten by conditions. Sometimes the system that worked beautifully yesterday becomes the wrong language tomorrow. That is not failure in the ordinary sense. It is a deeper kind of instability, one that lives inside the very possibility of law. You may feel by now that the universe is not merely enigmatic, but self-contradictory. That feeling is dangerous if taken too literally, because the universe does not need to be logically inconsistent to be deeply unfamiliar. But the emotional truth remains. More and more observations seem to land slightly out of alignment with the story we thought we were living in. The gaps are not dramatic enough to trigger consensus collapse, but they are persistent enough to prevent closure. This is why the unease lingers. It has nowhere cleanly to go. Every time you think the pattern is closing, another anomaly appears. Every time a theory promises reconciliation, a new measurement arrives to complicate it. The result is not chaos exactly. It is something worse for the human mind: unfinished stability. Unfinished stability is the state in which a house is still standing, but you hear the beams at night. The windows remain intact, but the frame is settling in unfamiliar ways. Nothing has fallen, yet nothing feels entirely settled anymore. That is where modern physics seems to be living, at least emotionally. The great success of the last centuries has not disappeared. It is still all around us in technology, prediction, engineering, and astronomical precision. But beneath that success, the foundational picture is becoming harder to hold in a single coherent mind. The laws still work, but the reasons they work look less complete every year. The universe still behaves, but the behavior no longer guarantees simplicity. And the more carefully you examine it, the more it appears that the consistency itself may be local, approximate, or temporary. So you begin to ask the kind of question that feels almost forbidden, because it threatens the grammar of reality. What if the universe is not following its own laws because the laws are not the final authority? What if the laws are generated, selected, or stabilized by processes beneath them? What if what we call physics is the visible crest of a deeper motion we cannot yet perceive directly? This is where speculation becomes unavoidable, but not irresponsible. Grounded speculation is what happens when the data run ahead of the language. Maybe the universe contains hidden layers, not as a fantasy of secret tunnels and cosmic machinery, but as a serious possibility that our current frameworks are only surface-level descriptions. Maybe there are regimes of reality where constants vary subtly. Maybe there are domains where our equations are not broken, merely incomplete. Maybe the deepest structure is not made of things at all, but of relations, information, or something stranger still. But even if that is true, it does not restore the old comfort. It only moves the question downward. What governs the deeper layer? What stabilizes it? What keeps it from drifting the way the visible layer seems to? If the universe has hidden architecture, then that architecture also demands explanation. And if that explanation leads to another layer, the stack continues. There is a point where deeper stops feeling like progress and starts feeling like descent. That is the emotional shape of this entire problem. You are not climbing towards certainty. You are descending through increasingly thin membranes of understanding, each one capable of holding the world together just long enough to reveal the next crack. The strange thing is that this descent does not feel like a fall, so much as a slow loss of grip. You do not suddenly stop believing in physics. You simply notice that physics no longer feels like a finished sentence. It feels like an unfinished draft, full of sections that work beautifully and sections that hint at revisions still to come. And because the universe does not pause while you revise your description of it, the discomfort becomes unavoidable. Reality keeps happening. Light keeps traveling, stars keep burning, galaxies keep moving. But the sense that you understand the terms of that motion becomes more fragile with every contradiction. You are left in the unsettling position of living inside a world that is operational, but not fully readable. Perhaps that is the truest form of existential unease. Not the fear that everything will disappear, but the fear that everything is already present and still not fully knowable. The universe does not need to collapse in order for your confidence in it to erode. It only needs to become less consistent than expected. A few anomalies, a few tensions, a few conflicts that refuse to disappear, then a pattern, then more than a pattern, then the suspicion that the pattern itself may be the real message. And once that suspicion takes root, every stable surface in your mental world acquires a second meaning. It is not just a surface. It is what remains visible while something deeper stays hidden. That hidden thing may be mundane. It may be profound. It may be a missing physical principle waiting to be discovered with future instruments, or a correction to current models, or a yet unknown mechanism that stitches together relativity and quantum behavior. But the very possibility that it exists changes the emotional climate, because now the universe is not just mysterious, it is active in its mystery. It appears to resist a complete description. It produces contradictions that are not easily isolated. It makes your best theories fight each other in public. It reveals that the architecture of reality may be less stable than the confidence with which you move through it. And that is why the feeling grows worse, not better, as the evidence accumulates. Usually more evidence means more certainty. Here, more evidence seems to mean more pressure. The more carefully you map the world, the more places you find where the map bends or tears or overlaps itself. At some point, you stop asking whether the universe has one flaw and start asking whether your notion of a fixed, universal law was ever enough. Maybe the universe does not obey one neat set of rules from top to bottom. Maybe it behaves according to regimes, contexts, transitions, and depths that only resemble a single law from far enough away. Maybe what you call law is just the silhouette of a far more complicated reality. If so, then the universe is not simply strange. It is unstable in the deepest possible sense, not necessarily falling apart, but refusing to stay conceptually still. That instability may not threaten your life tomorrow, and that is part of what makes it so unnerving. The world remains usable. Gravity still works. Suns still shine. Your room remains a room. Yet somewhere underneath that ordinary continuity, the assumptions are churning. The cosmic expansion does not quite match the expected story. The quantum world will not fully surrender its meaning. Gravity refuses to merge cleanly with the smallest scales. The constants are watched for drift. The theories remain powerful and incomplete. The pattern keeps extending. The unease keeps deepening. So you are left with a universe that feels like it is beginning to reveal not a secret, but a fracture in the very idea of finality. You are not being offered closure. You are being shown that closure may have been a temporary convenience. And the most unsettling possibility of all is that this is only the beginning, that the contradictions you can measure now are merely the first signs of a larger shift you are not yet equipped to name. If reality is changing, evolving, or exposing limits in the laws you thought were absolute, then the question is no longer whether the universe is strange. The question is whether the strangeness is stable enough to stay hidden. Because if the rules are not final, if they are not fully universal, if they can drift at the edges or emerge from deeper conditions, then what else might be waiting in the layers beneath your perception? What else has been consistent only because the part of reality you can access has held together long enough for you to mistake it for permanence? And if the universe is already showing signs that it may not be following its own laws as cleanly as it should, then what happens when the exceptions stop looking like exceptions and start looking like the true shape of the system? You want the answer to be a clean correction, a missing equation, a final unifying principle. But the universe has not offered that comfort. It has only offered the growing, unbearable suspicion that the order you trusted may be thinner than you ever imagined. And once that suspicion settles in, it changes the way you hear every claim of certainty. A law that once sounded eternal now sounds conditional. A constant that once seemed immovable now sounds watched. A theory that once felt like a window into reality now feels like a frame placed over it. Useful, precise, and possibly incomplete in ways that matter more than anyone wants to admit. You begin to understand that the universe does not need to shatter dramatically to become frightening. It only needs to stop being fully reliable. The mind can survive mystery, but it struggles with a cosmos that appears to revise its behavior at the level where behavior itself becomes law. That is why the current scientific landscape feels less like a collection of isolated puzzles and more like a slow, accumulating failure of confidence. The disagreements are not always loud. They appear as subtle mismatches, stubborn tensions, statistical fractures, values that should align but do not quite meet. Each one is small enough to debate and large enough to matter. Each one gives hope to a future explanation while quietly eroding the simplicity of the present one. The universe seems to be speaking in a language of near misses, as if it is correcting your assumptions without yet revealing the correction. You can keep translating, but the sentence grows harder to finish. In moments like this, it becomes tempting to imagine a final theory as a kind of rescue raft, something elegant enough to float above the chaos and restore the old feeling of order. But what if the final theory is not a raft? What if it is a map of a shoreline that keeps changing shape? What if the deeper truth is not a final answer, but a deeper instability? One that explains why every previous answer eventually begins to creak? That possibility is harder to accept because it forces you to abandon the fantasy that the universe is built like a puzzle made by a patient designer, with one solution waiting to be uncovered. Instead, it would mean the universe is more like a living process, and processes do not always preserve the same rules as they unfold. This idea becomes especially unsettling when you think about the earliest moments of existence. Cosmology asks you to imagine conditions so extreme that ordinary intuitions fail almost immediately. Time may have behaved differently. Space may have been shaped differently. The forces we know may not yet have separated into the identities we assign them now. In those first moments, physics becomes less like a familiar machine and more like a transformation in progress. That is already strange enough. But if the laws themselves were not yet fixed, or were in some sense still becoming what they are, then the early universe was not just a hot beginning. It was a period of law formation. The origin of matter would then be inseparable from the origin of rule. The universe would not simply have started. It would have stabilized into something we mistake for permanence. The same unsettling possibility follows you into the black hole problem. At the horizon and beyond it, gravity becomes so intense that the intuitive separation between inside and outside, before and after, begins to blur. General relativity says space-time can curve without limit in certain mathematical descriptions. Quantum theory insists that information, uncertainty, and fluctuations matter in ways the classical picture cannot ignore. When you combine them, you discover a place where the laws seem to demand incompatible things. Black holes are not just mysterious objects. They are laboratories where the universe appears to confront itself. And in that confrontation, the question is not only what happens to matter, but what happens to the rules when pushed past the edge of their familiar territory. There is something deeply human about wanting the universe to be stable even when it is unknowable. Stability means survival. Stability means a world that can be trusted from one moment to the next. The fear behind these scientific tensions is not just that we lack knowledge, but that knowledge may not guarantee reassurance. You can know that the Earth orbits the sun and still feel safe. You can know that the universe is vast and still feel at home. But if the very framework of law can show cracks, then knowledge no longer guarantees stability. It only guarantees that you are aware of the instability. Awareness is not the same as control, and in this context, it can feel worse. The universe becomes more unsettling as the anomalies become harder to quarantine. A discrepancy in the cosmic expansion rate is not just a number problem. It touches the history of the cosmos, the age of structures, the nature of dark energy, and the assumptions built into how we infer the past. A deviation in a particle experiment is not just a lab curiosity. It may point toward new physics, hidden interactions, or subtle effects that current models cannot contain. A stubborn tension between datasets is not just methodological clutter. It may mean that the same phenomenon is wearing different masks depending on the lens you use. Each time that happens, the universe seems less like a fixed object and more like a multi-layered negotiation between observation and reality. And then there is the vacuum, that supposedly empty backdrop against which everything else occurs. In modern physics, emptiness is not empty. It is a restless sea of fluctuations, fields, and latent structure. Even the void has texture. Even nothing is not nothing. That alone is enough to unsettle the old picture of a quiet, self-contained cosmos. Because if the vacuum is active, then the universe is never truly static at its foundations. There is motion beneath stillness, activity beneath silence, potential beneath apparent absence. The deeper you go, the less the world resembles a solid object, and the more it resembles a dynamic event. That is a profound shift. Events can unfold, events can transform, events can destabilize. You may have noticed that much of the discomfort here comes from one repeated realization. The universe keeps refusing to behave like a finished system. Finished systems are predictable in the way a sealed machine is predictable. They may be complicated, but their principles are set. What is happening now feels more like an ongoing construction site, where the scaffolding is still visible and some of the beams do not yet agree on where they belong. That is not how scientific language usually speaks, but it is how scientific tension feels when you stand close enough to hear it. The existing models are not useless. Far from it. They are brilliant, powerful, astonishingly effective, but they are increasingly beginning to feel like local successes inside a larger incompletion. There is also the difficult possibility that incompletion may be the wrong word if the universe is not heading toward completion at all. What if the laws are not converging toward a final elegant structure but drifting as part of a larger cosmic history? Some ideas in physics already entertain the possibility that constants might vary, that symmetries might break differently in different conditions, that what we call fixed may have emerged after an earlier phase of the universe. If so, then the deep past is not only hidden from view, it may be fundamentally different from the present in ways that make our modern categories feel provincial. The universe would have a biography, not merely a blueprint, and biographies change over time. Once the word biography enters the picture, the emotional tone shifts again. A biography can be coherent without being stable. A living thing can remain itself while transforming. A universe with history is no longer a machine waiting to be decoded. It is a process that has already undergone transitions you can scarcely imagine. That thought can be beautiful, but it is also deeply destabilizing because it removes the last fantasy of timelessness. The cosmos is no longer a frozen equation, it is a becoming. And if becoming is built into reality at the deepest level, then the laws are not commandments carved outside time. They are part of the unfolding. At this point, the temptation is to retreat into a simpler story. Maybe the measurements will converge. Maybe the anomalies will vanish. Maybe future data will restore a cleaner picture. And sometimes that will happen. Science does correct itself. It discards false leads. It absorbs surprises. It survives by revision. But the reason this moment feels different is not that one surprise survived too long. It is that too many surprises are surviving together. The pattern recognition is no longer optional. The contradictions are not isolated in one corner. They are distributed, stubborn, and increasingly interdependent. The universe does not look broken in a single obvious place. It looks strained across multiple boundaries at once. That strain is what makes the possibility of deeper structure so compelling. If the current layer of laws is under stress, perhaps there is a hidden mechanism supporting it, or a broader framework from which these laws emerge like the visible edge of something larger. But even that hope comes with a shadow. A deeper framework would need its own consistency, its own stability, its own explanation. So the question never ends. It only descends. If the universe is made of layers, then each layer that explains the one above it also introduces a new frontier of uncertainty below. The mystery does not disappear. It stratifies. You can feel now how this becomes a psychological descent as much as a scientific one. At first you want a model, then you want a correction, then you want the correction to hold, then you want the holding to mean something. Then you realize that meaning itself depends on the stability of the framework you are standing in. The universe, once trusted as the great external certainty, becomes a mirror of your own limits. The discomfort is not that it is incomprehensible, it is that it may be comprehensible only in pieces, and those pieces may not fit together permanently. You are left with partial truths that work until they don't. This is why the phrase, "the universe may be unstable," lands with such force. It does not mean everything will explode. It does not mean every law will fail tomorrow. It means that the very thing you relied on as ultimate may itself be contingent. That is a deeper threat than chaos, because chaos is still a kind of order with low predictability. Instability at the level of law suggests that predictability itself may be borrowed. The universe could remain mostly coherent while still being, at a fundamental level, less settled than anyone hoped. That is a chilling possibility because it leaves you with no dramatic event to point to, only an increasingly persuasive pattern of slippage. And slippage is exactly what the evidence begins to resemble when you let the whole picture come into focus. Not one grand contradiction, but many small ones drifting in the same direction. Not a total collapse, but a growing inability to keep all the pieces aligned without strain. Not the end of physics, but the feeling that physics is standing in front of something larger than its current vocabulary. The current laws do not fail loudly enough to be dismissed, and not quietly enough to be ignored. They persist while wobbling. They succeed while hinting that success is not the whole story. That is what makes the situation so uncanny. It is not failure. It is instability disguised as functionality. There are moments in history when a civilization realizes its map of the world is not wrong in detail, but wrong in scope. You may be living through one of those moments in physics, not because the old theories are useless, but because they are beginning to appear as special cases of something broader, something that has not yet fully disclosed itself. If so, then the current anomalies are not accidents. They are boundary markers. They are the places where the visible order runs into the edge of a deeper one. That edge is what you are sensing when the data stop agreeing with each other, when the models start contradicting one another, when the universe seems to be pressing back against the very idea of a final description. The more you reflect on it, the more the old reassurance feels like a thin membrane. Behind it is the possibility that reality is not a single static domain, but a layered environment with transitions, thresholds, and hidden dependencies. On one layer, everything looks regular. On another, the regularity may be derived. On another still, the derivation may itself be temporary. That structure is not just philosophically unsettling, it is scientifically plausible enough to be impossible to dismiss outright. And once you take it seriously, the question of what it means for a law to govern the universe becomes far more complicated. Maybe laws don't govern, maybe they emerge, maybe they describe, maybe they are the visible edges of something that behaves differently when viewed from another scale entirely. If that is true, then our confidence has been based not on falsehood exactly, but on limited visibility. That is a harder thing to confront, because it does not permit simple blame. The universe did not lie to you. It only showed you what could be seen from where you stood. The laws worked because they were real within the range where they worked. The problem is that the range may not be the whole, and when you realize that, the world becomes larger and less secure at the same time. Larger because there may be more to reality than you imagined. Less secure because the part you know may not be the part that remains unchanged forever. So you keep looking. Humanity keeps looking. That is what it does when certainty starts to crack. Better instruments, better surveys, better theory, better statistics, better questions. But with every improvement, the possibility also grows that the universe is not merely waiting to be found. It may be responding in its own quiet way to the act of being examined, not in a mystical sense, but in the profound sense that observation reveals the seams of the system. The more exact the question, the more visible the inconsistency. The more refined the lens, the more obvious the mismatch. It begins to feel as if reality is tolerating scrutiny while refusing full compliance. That refusal is the core of the unease, not because compliance is owed, but because the expectation of compliance is built into the very idea of law. You do not call something a law if it applies only sometimes in ways that cannot be fully anticipated. Yet that may be closer to the shape of reality than the clean textbook version ever suggested. Laws may be robust, but not absolute. They may be local, but not universal in the way imagined. They may emerge from deeper conditions, rather than standing alone. And if so, then the universe is not a courtroom where laws rule from above. It is a shifting architecture where regularities hold only because the conditions beneath them remain favorable. That image is harder to live with than a universe of eternal laws, because it implies that stability is something earned by circumstances, not guaranteed by essence. The cosmos becomes less like a statute and more like a weather pattern, mostly reliable, often beautiful, but capable of changing in ways that alter everything without warning. You can still study weather, you can still predict it, you can still live within it, but you never confuse it with permanence. Maybe reality deserves the same humility. Maybe the great mistake was assuming that the patterns we observe are not only real, but eternally so. Maybe the universe has been teaching us, through every anomaly, that patterns can be real and still temporary. And if that is true, then the real question is not whether the universe is violating its laws. The real question is whether the laws were ever the kind of thing that could be violated at all. Perhaps what looks like violation is transition. Perhaps what looks like contradiction is overlap between regimes. Perhaps what looks like instability is the visible sign of a deeper reorganization of reality itself. But even that hopeful reframing does not erase the discomfort, because transitions are exactly when things become unpredictable. Overlap is exactly when models conflict. Reorganization is exactly when the familiar stops matching the present. So even the more generous interpretation leads back to the same feeling. The universe is moving under your feet. That is where the open-ended dread becomes most potent, because you can no longer pretend the issue is only one branch of physics or one impossible measurement. The issue has become structural. It touches the reliability of law, the unity of theory, the limits of observation, and the meaning of consistency itself. You are not just watching science revise a detail. You are watching reality challenge the assumptions that make revision possible. And the more you consider that challenge, the more difficult it becomes to imagine a final, closed answer that leaves everything exactly as it was before. So the night stretches out. The equations remain incomplete. The observations remain stubborn. The theories continue their careful argument. The cosmos keeps expanding. The quantum world keeps refusing intuition. Gravity keeps bending space-time, and somewhere in the space between these truths, the pattern keeps becoming harder to ignore. You started with a universe that seemed solid, lawful, and quietly dependable. You end in a place where even law feels like a temporary arrangement, a fragile coherence held together by rules that may themselves be changing, emerging, or failing to describe the whole. And if that is where we are, then perhaps the deepest surprise is not that reality is strange. It is that it may be stranger in motion than at rest, which leaves you with the question that no completed theory has yet managed to close. If the universe is not following its own laws cleanly, and the signs of that refusal are spreading, what exactly is doing the following, the changing, or the rewriting beneath the level where the laws themselves can see it? You keep waiting for the feeling to pass, but it does not pass in the way ordinary uncertainty passes. It lingers like a low electrical hum beneath everything you think you know, subtle enough to ignore for a moment, persistent enough to return the second you stop trying to outrun it. That is the terrifying part now. Not that the universe has become obviously broken, but that it still appears functional while refusing to remain fully trustworthy. The stars still shine, the equations still work, the experiments still produce results. And yet the more carefully you look, the more that functionality resembles a surface tension over something much less stable underneath. It is as if reality has begun to behave like a disciplined voice that is trying very hard not to crack. You might want to believe this is just how discovery feels, that every era thinks it is living at the edge of some grand collapse in understanding. But there is a difference between ignorance and instability. Ignorance is waiting in the dark for a light to be switched on. Instability is standing in a lit room and realizing the floor may not hold the same way from one moment to the next. That is why the current picture is so difficult to absorb. It does not merely say, "We do not know enough yet." It says that the thing doing the knowing may be standing inside a system that is more conditional than it has ever been willing to admit. The laws may still be true, but perhaps only under circumstances more fragile than anyone imagined. And fragility, once seen, is impossible to unsee. This is where the story stops being about isolated scientific surprises and becomes something closer to a confrontation with the structure of comprehension itself. If the universe can present one set of rules here and a slightly different emphasis there, if the same cosmic history can be read in ways that do not quite agree, if gravity and quantum behavior continue to resist complete unification, then you are no longer dealing with a simple gap in knowledge. You are dealing with the possibility that reality is not organized around a single universal transparency. Some parts may be crisp, some may be layered, some may be emergent. Some may be inaccessible by design, not because anyone designed them in a human sense, but because the universe itself may not be built to be fully legible from inside one of its own regions. That thought should feel abstract. Instead, it feels like a door closing very gently. And once that door begins to close, you notice how many assumptions were standing in the hallway behind it. You assumed constants were constant because stability looked like the default. You assumed laws were laws because the word itself carried an air of permanence. You assumed the same grammar of reality would hold everywhere because it had held almost everywhere you could test. But now even the exceptions are multiplying in a way that makes permanence seem less like a fact and more like a local convenience. Perhaps the universe is not violating its laws at all. Perhaps the laws are what we call the pattern after it has been reliable for long enough to earn a name. That does not make the pattern less real. It makes it more vulnerable. Real things can change. Real things can drift. Real things can fail to remain what they seem to be. And if that is true, then the deepest fear is not chaos. It is evolution, without reassurance. A cosmos that changes its own behavior is not necessarily hostile, but it is no longer fixed. And fixed things are what allow minds like yours to settle. Without fixed rules, every prediction becomes slightly more provisional. Every certainty acquires an expiration date. Every model becomes an instrument tuned to a version of reality that may not stay still long enough to be final. That is what makes the current moment feel so strangely intimate. The universe is not simply presenting puzzles for scientists to solve. It is exposing the limits of the assumption that reality itself is the same kind of object from one scale to the next. The more you sit with that, the more you sense that the old picture of the universe was always a little too clean. It was useful, yes, in some domains, astonishingly accurate, but cleanliness can hide a lot. A shoreline looks smooth from afar, even when it is made of jagged stone. A glass surface looks still while microscopic vibrations continue beneath it. Maybe the laws of physics are like that, a visible smoothness created by the averaging of deeper turbulence. Maybe what looks like universal stability is the emergent appearance of countless interactions that are only stable because they have not yet crossed the wrong threshold. If so, then the universe is not lawless. It is delicately lawed. That is a much more fragile thing. Fragility at this level changes the emotional meaning of every scientific advance. Every new telescope, collider, detector, or computational model does not merely reveal more of reality. It also reveals how much of reality remains resistant to being turned into a single unified picture. The more precision improves, the more the remaining disagreements matter. They are no longer noise at the edge of a nearly complete map. They are the lines where the map itself starts to lose authority. Some tensions may eventually fade, but not all of them can be dismissed as temporary. Too many have the same shape. An expectation meets an observation and finds the world a little less obedient than assumed. That repeated non-compliance is what gives the pattern its menace. And maybe that is the point where the human mind begins to project a kind of emotional mirror onto the cosmos. Because the universe, in this moment of contradiction, starts to resemble your own experience of instability. The sense that things are mostly fine until they suddenly are not. The feeling that continuity can be preserved right up until the instant it cannot. The recognition that what seems permanent may only be sustained by conditions you do not control. That parallel is unnerving because it makes the cosmic problem personal. You are not only trying to understand a strange universe. You are trying to understand whether stability itself is ever truly guaranteed anywhere. If the cosmos can drift, then maybe so can everything else you trusted to be solid. Yet even in the midst of that unease, there is a kind of terrible beauty to the situation. The universe is still speaking, just not in the voice you expected. Its contradictions are not random static. They are structured tensions, hints that the familiar language is reaching its limit. That means there is still something to learn, even if what you learn is that your current framework is smaller than reality. And perhaps that is why the fear persists without becoming despair. The mystery is not empty. It is active. It has shape. It is drawing a boundary around human certainty and making that boundary visible at last. You may not like what that reveals, but you cannot deny the elegance of the reveal itself. The most unsettling possibility now is that there may never be a final moment when everything clicks and the whole universe relaxes into a single, perfect explanation. That ending, so satisfying in stories, may be a human fantasy carried over from a world that is too complicated to fit inside it. What if understanding is not a destination, but a series of provisional settlements with a reality that never stops shifting at the margins? What if every answer is only a temporary truce? If so, then the universe is not failing to obey its laws so much as refusing to freeze into the version of itself that would make those laws final. That possibility is both intellectually exciting and spiritually disorienting. It means the cosmos is not a solved object. It is an ongoing negotiation. And negotiations can fail. They can stall. They can change terms without warning. They can reveal that the side you thought was dominant was only one layer in a more complex arrangement. That is why the pattern of anomalies matters so much. It is not that each one individually demolishes physics. It is that together they imply the existence of a larger context in which current physics is incomplete. Perhaps there are hidden dimensions, perhaps hidden symmetries, perhaps hidden dynamics in the vacuum, perhaps forms of matter or information we have not yet conceptualized, perhaps laws that evolve with the universe itself. None of these ideas is a verdict. They are all attempts to prevent the same disturbing realization from becoming too direct. The visible rules may not be the deepest ones. If you let that realization sink in fully, then the universe begins to feel less like a finished place and more like a threshold event that is not yet finished unfolding. The laws we trust may be the equivalent of shorelines drawn by tides that are still moving. The deeper structure may be stable or not. It may be expressive or not. It may even be something that no present theory can comfortably describe without distorting it. That does not mean science is approaching failure. It means science is approaching a boundary where the usual confidence of model building meets the possibility that the models themselves are only local approximations to a reality that does not care about being simplified too early. And now the central fear can finally be said plainly. What if the universe is not just strange but unstable in a way that we have mistaken for complexity? What if the apparent consistency of nature has always been conditional, and we are only now reaching the conditions where the strain becomes visible? What if the laws are not being broken because something is wrong with the universe, but because we are beginning to see the universe where its own rules grow thin? That possibility does not offer closure. It offers depth, and depth is not always comforting. Sometimes it is just another word for falling further into the dark while still seeing the shape of the wall beside you. So the question remains suspended and unresolved, with more force now than when the story began. If reality is not reliably following the laws we built our certainty around, and if the violations are multiplying, converging, and growing harder to explain away, then what exactly is the universe obeying instead?